Today, we are finding solutions graphically. So we're looking at a graph, and we are trying to determine what the answer to the equation is. Remember, solutions can mean a lot of different things. They can be called zeros. They can be called solutions. They can also be called x-intercepts. It doesn't matter what you call them. They're all talking about the same thing. It wants to know where the graph crosses the x-axis. Really big, somewhere. So let's look at some pictures. The only thing I care about is where the graph crosses the x-axis. So this graph crosses the x-axis here and here. So I would say that my solutions are x equals -3 and 1. For this one, my graph doesn't really cross, but it touches the x-axis here at x equals 1. Well, that counts as a solution. It would be x equals 1. This graph never crosses the x-axis. So this graph would have no solution, or an empty set. When we're doing systems of equations, meaning that we have two different graphs on the same coordinate plane, we don't care about where the graph crosses the x-axis. We want to know where the two graphs cross. We don't care about where the graphs cross the x-axis. It's where they cross each other. So your answers for these should always be points. So in this case, these two graphs, the red line and the blue line, cross each other at the point 2, -3. And that's your answer. Here, the red line and the blue line cross each other right there, which is the point 1, 1. Be careful how you name your points. If this were a multiple choice question, you better believe that they would maybe flip-flop those two, just to make sure you know how to name a point. Here, the graphs cross in two places. One answer is the point 4, -6. The other answer is the point 2, whoops, see I messed up. It's point 0.02. So make sure you include both points. If the graphs cross 3 times, you would write down 3 points. In this case over here, this blue parabola doesn't cross the red line at all, so you would say you have no solution. We've already talked about this a little bit, but when you're solving a system of inequalities, here are some nice little steps for you to remember. You graph them on the same coordinate plane. You want to make sure you isolate any x values or any y values so you can graph them in y equals mx plus b. We've got solid lines versus dotted lines, and make sure you shade. So, first one, it already looks like y equals mx plus b. Your m is -1. Your b is -2. So you start at -2. You go down 1 and over 1. Down 1, over 1. Making sure you fill your entire coordinate plane in both directions. Let's see. There's no equal to, so this is a dotted line. Now we got to talk about our shading. It says the y's are greater, or the y's are bigger. So you want to shade above the line. Now let's look at the next one. The next one is not in the proper form. It is in what we call standard form, and we do not like that. So let's rearrange it. I'll subtract the 3x over. So now I have -y is greater than or equal to -3x minus 1. Y is technically not by itself. I have to divide everything by -1. So when I divide anything, when I have an inequality, and I divide by a negative, I have to remember to flip. So this flips in the opposite direction. Now I just do some simple algebra. Negative 3 divided by negative 1 is 3. So it's 3x. And then negative 1 divided by negative 1 is positive 1, so we say plus 1. And now we graph again. Positive 1. And we're going to go up 3 and over 1. And again, we want to fill the whole coordinate plane. Now, let's talk dotted to solid for a minute. Since it's equal to, it's going to be a solid. Make sure that looks nice and solid when you're graphing it. And then y is less than, so we're going below the line. So we're here. And recall, whenever we are graphing two inequalities in the same coordinate plane, your answer is where the two shaded regions overlap. So technically, this is my answer. Now, second part of the direction, say name an ordered pair that's a solution to the equation. Well, there are thousands of answers here. It doesn't really matter. I colored in my coordinate plane so much that it's almost hard to read. You just have to pick any point in the shaded region, in the double shaded region. So maybe this point over here. That's the point 1, 2, 3, 4, 5, 6, 7. 1. You can pick anything. You could pick a point down here or up here. It doesn't matter. So that's all we have for solving equations graphically. Show me your notes and I'll get you your handout.